Okay, here we have some problems that again have two radicals in them, but they're different than the ones we did in the last video. In the last video we had a radical equal to a radical. This time we have a radical minus a radical equals 1. When we're faced with this type of situation, we have to work this in steps. There's just no other way to do it. What we want to do is we want to move this term over to the other side so that we have a radical on one side, everything else on the other. A radical on one side. So that's going to give us the square root of x plus 1 equals 1 plus the square root of x minus 2. Now I just added this to both sides so that we would, the opposite of adding the root would be the opposite of subtracting the root would be to add the root. Okay, now that we're at this stage, we need to get rid of one of the radicals first. So we have to square both sides. Now remember, you're squaring both sides, not every item. So in squaring the left side, it undoes the radical and we have x plus 1 equals. Over here on the right hand side, this literally means that we have to write this out and multiply it to itself. So if you need to write that out, then you absolutely should, and then perform the multiplication. So 1 times 1 would be 1. Now I'm going to do this distribution and this distribution and combine at the same time. So here we would have one of those radicals. The inside term would be one of those radicals. So when I combine those, that would be 2 of those radical x minus 2's. If you need to do that out in small steps and then combine, that's fine. And then our last terms, the radical times itself, will basically just get rid of the radical and we have what's left underneath there. Okay, now we still have a square root. This is what will happen. When you have a situation like this, it's not just radical equal to radical. You're going to end up having to square twice to get rid of both of them. So at this stage, let's go ahead and combine like terms. I want to move everything over to the left except this radical. So I'm going to start with my x's. If I subtract x from both sides, that'll get rid of it here. And, well, it'll get rid of it here too, won't it? Because x minus x is nothing. I'm also, I'm going to rewrite this now. So now I have 1 equals, I can combine the 1 and the negative 2. That would be a negative 1 plus 2 square roots of x minus 2. And now let's add 1 to both sides so that we have 2 equals 2 radical x minus 2. And again, I think with this one especially, it's going to be very easy to do. Let's divide everything by 2 so that we can get rid of that and get that radical all by itself. So this would be 1 equals the square root of x minus 2. Now we can get rid of that radical by doing the opposite, which would be to square both sides. So now we would have 1 equals, oops, there we go, x minus 2, and now solving, we would get x equals, we add 2 to both sides, we get x equals 3. Now we again do need to check this to make sure that we're right. So if we have the square root of, if we set our answer as 3, 3 plus 1 minus the square root of 3 minus 2, that's supposed to equal 1. So the square root of 3 plus 1 would be the square root of 4, which is 2. And here, the square root of 3 minus 2 would be the square root of 1, which is 1. And 2 minus 1 is 1. So that does check. That tells us that our x value is actually a 3.